good evening, and thanks for joining this session. My name is Muthuramakrishnan. I'm one of the solutions architects here at Google. So in this session, we'll be talking about APIs, microservices, and the service mesh. So the goals of this session is actually to understand the value of the service mesh, the value of API management, understanding the continuum between API management and service mesh. So we'll also explore the relationship and the interplay between service mesh infrastructure and API management, when to use each, and how they compose. So everyone is on this journey, moving from monolith to microservices. Some started from service-oriented architecture, half step along the way. And in the microservices architecture pattern, an application is a collection of loosely coupled services. Services are fine-grained. The communication protocols are lightweight and simple. So if you look at why people are moving from monolith to microservices, there are several reasons. In case of monolith, the release units are quite large, right, compared to microservices where your release units are quite small. And if you look at monoliths, there is a strong coupling between the features and the services itself. And in case of microservices, there is looser coupling. And in case of monoliths, the automation is quite creaky. So let's say you're doing a change to your application. You'll have to deploy the whole application again. And in case of microservices, you could just update a small service that is responsible for that feature update. And finally, the tests, right? So in case of writing tests, the tests for monoliths are quite coarse. And in case of microservices, you can write fine-grained tests. So that's why people are actually moving to microservices from monolith architecture. And as we move on to this architecture, it gets quite difficult to manage these microservices. So as you break down a bigger monolith, you are actually getting a lot of thousands and thousands of microservices. And the whole point is actually to manage them efficiently so that you can get a better productivity. There's also another approach that people take, actually, to take the monolith itself and wrap it alongside an API. So in this case, what you end up with is a huge monolith application fronted by multiple APIs that are fine-grained and exposed to customers who are accessing these APIs. So if you look at what are APIs, APIs are actually the communication contracts. So essentially, if you look at all the, on the left side, you can see that there are client devices which communicate with your backend services, and they do this through APIs. So essentially, APIs are the communication contracts, and in case of the path of breaking down a monolith into a microservice, you end up having a lot of microservices that need to talk to each other, right? So in this case, you're going to end up with a lot of APIs, and you need to manage them efficiently, right? So essentially, the whole point of moving from a monolith to microservices is to get a fine-grained control. And by doing that, you're actually having a lot of APIs that are exposed through these thousands and thousands of microservices. Let's actually start, understand. Let's start to understand what a service mesh is, and let's try to build one actually, right? So if you look at the previous slide, you saw, we are actually trying to break the monolith into microservices. And when you do that, you're ending up with lots and lots of, small services. And the primary concern here is the first point is actually to make sure the services intercommunicate with each other. So what do you mean by services intercommunicating with each other? So before we had one monolith which did which served the purpose of two services, and then we broke it down into two services separately. And in this case, they need to talk to each other, right? And it can be over any protocol, HTTP, gRPC, TCP, any protocol, right? So essentially, in this case, the services needs to intercommunicate. Now, if you look at monolith, these services are actually alongside each other, and these are inter-process communications. And essentially, in that case, what happens is you don't really need to authenticate the call because you know that it's going to be coming from the same process. But when you break down this service, you're actually traversing a network. So service A is calling service B, which is traversing the network by itself. So we need to make sure the caller who's calling essentially in this case service A, which is calling service B, is authenticated and is authorized to call service B. So what we're doing is we're actually adding MTLS to make sure these services can talk to each other, right? So once we do that, we need to actually manage these certificates. So once you actually have, so this is service A talking to service B. If you look at thousands and thousands of microservices which needs to talk to each other, and you're going to end up with lots and lots of certificates that you need to manage. So it's better to actually delegate that to a system, which is basically a control plane, that can take care of all these things for you. So essentially what we are saying is, we are going to delegate some of these work that is done by service A to service B calls, which is basically mutual TLS and other authorization capabilities. And we are going to have a control plane which is going to manage on how this is going to happen. So apart from that, apart from service A calling to service B, the authorization aspect, we also have several other use cases where you need to check for policies like timeouts, circuit breaks, and everything else. So that is also now delegated to control plane. So what we're doing now is we're actually taking, we are trying to form a pattern of interaction where the control plane will let service A know how to call service B and what are the policies that it needs to go through, and vice, et cetera, et cetera. So we also want to provide services that other to essentially describe communication policies related to retries, timeouts, and authorization. Also, apart from that, we also want to understand telemetry from each service. Is the service working? Is there any performance issue, et cetera? So we need some sort of a monitoring system that can actually monitor calls from all these services and give you a single unified view of what's happening along the service mesh. So if you look at what we just did, so we told that to service A to talk to service B, there are a lot of things that needs to happen, like right from authorization, essentially policy checks, telemetry, tracing, et cetera, et cetera. So what's happening here is we are actually doing a lot of non-functional requirements. Essentially, we'll try and do this in the service itself. So what we're trying to do is we're actually trying to take this out of the service and then delegating it to another service by itself. So in this case, what we're doing is we're trying to add a separate proxy that can take care of all these things. So what is the advantage of adding a proxy? So this is the, this approach is called a sidecar approach. So what we're doing is we are actually taking all these capabilities that we just described and then delegating that to a sidecar. So when you insert the sidecar alongside your service in your Kubernetes pod, you can actually take, as a developer, you are just responsible for maintaining the code for that particular application and the service. So you don't really need to worry about the policy and everything else. You can just write a configuration that can be taken care, that will take care by the service mesh itself. So in this case, what we did was we had a control plane, which is going to store all the configuration-related data, and there is a proxy, sidecar proxy, which is bundled alongside all these services. So what happens here is you are basically telling the communication happens between, let's say a service A wants to talk to service B. So it initiates the call. The call goes to the proxy first. The proxy will identify, okay, the call needs to go to service B. So what is the URL for that in the cluster, in the services that we have deployed in Kubernetes? And it will go and discover the URL for it, and then call that particular service accordingly. Now, the service B has a proxy in front, right? So it understands what this call is, where this call came from, and then it will apply the specific policies that needs to apply for the service B, and then later it will give the call to service B. Now service B will respond back with the response it's supposed to give, and then the call goes to the proxy again. It hits the proxy of service A, comes back to service A. So essentially what's happening here is we are delegating all the non-functional requirements to the proxy, which can take care of these features for you. So specifically routing, secure naming, certificate issuance, policy enforcement, and reporting. So this is what Istio does, right? So Istio as a service mesh provides it with the exact same feature. So when you install Istio on Kubernetes, you are actually getting all these features out of the box. Right from, for example, you've got Pilot, which is going to manage your Envoy proxy. So in this case, the proxy that is used is Envoy, right? And to manage that, we're going to use the pilot. And you've got Citadel, which is responsible for certificate issuance, right? Revoking, rotating, and everything else. And I've got something called Mixer, which we'll talk about a little bit in detail now. So Mixer is responsible for certain things. Number one, it does two actions. One is check, the other action is report. So in check, you can actually, when the call comes to, goes through the service mesh, you can do certain types of checks, like for example, API key verification, token verification, et cetera, et cetera. And this will give context on where, who's the caller and who needs to access what service, et cetera, right? And it also provides you with an extendable interface where you can plug in external adapters. Like for example, you can see there is an Apigee adapter where you can actually plug in the Apigee adapter that connects to the Apigee API management platform on the cloud, and where you can actually manage your keys, tokens, and everything. And there is also a login plugin where you can actually log in to Stackdriver. Like any logs from this application can go into Stackdriver, and essentially you have a central unified interface for monitoring the entire service mesh. So in this case, we saw how Istio is actually working. So we've got a proxy, a sidecar proxy, which is going to do all the work in terms of handling your non-functional requirements. And you've got the control plane, which consists of Pilot, Citadel, and Mixer. So Pilot is responsible for actually managing the proxy, right, the Envoy proxies. And we've got Citadel, which is responsible for managing the certificates that is issued to all these proxies. And at last, you've got Mixer, which does two tasks. One is check, another is report. So essentially, check is to check for API keys, tokens, and everything. And report is to basically report analytics to any of your tools that you might have. Not always, your calls are internal. Sometimes you need to allow external calls. So for example, let's say an external call comes into the service mesh. How do you allow it? So that is allowed through an ingress gateway. That's again an Envoy proxy that sits inside your cluster. And essentially the application will call using JOT plus TLS onto this gateway, and that will in turn forward the call to the respective service. Now, it's also not always that you are calling only internal services. You might also want to call third-party services where you might need to take go out of your network. So in this case, we have also got an egress gateway which connects to your external applications, and that can also be done through JOT plus mutual TLS or any other authentication mechanism that you seem working. So what we have now is actually the entire architecture of calls going from your internal egress gateways to your external egress gateway to the external application, traversing the microservice, the service mesh that we have, controlled by the control plane at the bottom. So just a quick summary of why use a service mesh. So we started with actually taking a monolith and then breaking it down to multiple microservices. When we do that, we are ending up with lots and lots of small services that needs to be connected together. That's the first point. And the second thing is now, before the monoliths, the calls between the process where the services were inter-process, and there is no need for authentication. And in this case, now we move to a microservice-based architecture, and we need to make sure that the calls from service A to service B are secure enough. So that's another reason that we use a service mesh. Third is basically control. We need to make sure what type of calls are allowed and what type of calls go through and what type of calls does not go through the network or the mesh. So in this case, service A can call service B, but service A cannot call service C. So these are some of the rules that you can apply on the service mesh level so that it can help you focus on writing code, the business logic, rather than doing this non-functional requirements. And at last, we need to make sure all these microservices run efficiently and in a tandem way. So we need to make sure that all these services are monitored, and essentially we need to look at logs and some monitoring reports to understand what's the problem. So that's the reason why we are using service mesh. At the end of the day, we need to make sure all these non-functional requirements are taken out of the developer's role and then delegated to a service mesh. So now we'll come to APIs, right? So we saw a bit about what APIs were. So APIs were the communication contracts. So generally, we use APIs when we have to do an external call. Like, for example, external integration. Let's say you've got an Android application or a Google Assistant that is going to connect to our APIs. So we think about having an API gateway in front, exposing the APIs. And these APIs are generally secured through API key or OAuth 2.0 or any other security mechanism. So essentially, that's when we think about using an API gateway. And alongside, essentially, if you think about exposing these APIs to your third-party consumers, you also think about various other things, the first thing being developer portal, where you need to actually expose these APIs onto a neatly built portal where the developers can look at the documentation of this APIs and then self-service, obtain a key, and then start accessing these APIs. So after that, you might also want to understand the API analytics, like for example, how many calls came from the mobile app, how many calls came from the web app, and certain other business metrics like, okay, what was the amount in transaction that was carried out in the last month, et cetera, et cetera. So this is where we will actually think about using an API management layer that is actually fronting a legacy application and a monolith application, right? So, and it can be of different formats. The protocol can be, you can have HTTPS SOAP or HTTPS REST, so you can have different application talking in different protocols, right? So that's when we'll think about using an API management platform. So again, why use API management? So we spoke about service mesh, the use of service mesh, where we will use it. And then now we are talking about API management, where we'll use it, right? So first one, the discover part. We need to make sure these APIs that we build for external purposes are discoverable. So that's where you will think about having a developer portal that actually serves your end consumers these documentation that has been automatically generated. And number two is modernize. So you might have a lot of legacy applications that talk in several legacy protocols. So you need to make sure these are modern enough to cater to the new end customers that are the devices that need new protocols. Like mobile devices can talk in REST, and SOAP is not a way to do it, right? So you might want to do SOAP to REST conversion, and this is one way you can use API management to do that. And number three is report. So you need to understand both functional and and business reports. Like for example, you need to understand, okay, what was my latency in the past 1 month? Like what was the peak latency? What was why it happened? What was the events that led to it, etc. And you might also want to understand the business side of things, where you need to think about, okay, who are my top partners, who are my top apps, and how do they use these APIs, etc. And at last, you need to make sure these are monetized, the APIs. Like for example, you might have an API. Let's say you are a company that provides a lot of data, and you want to make money from usage of this data through the API that your consumers access. You can actually have rate cards and plans that actually take care of doing the monetization work for you. So that's why that's when we think about using an API management platform. So we spoke about how we need to evolve from monolith architecture to a microservice architecture. And having a microservice architecture also leads to having a lot of APIs, and how do you manage them as well. So let's take a quick example of, or the journey of how we would do this, right? So let's say you might have a monolith application, and you're actually going through the process of breaking it down to multiple microservices. And at the same time, you also want to expose these legacy services that you have to your end consumers in a modern consumable fashion. So that's when we'll also put an API management platform. So first thing that we do is you put an API management platform, and then we expose all these APIs that can be consumed in the modern way. So now starts the process of actually breaking down the monolith app into a microservice. So when we do that, we will start with creating some what we call as macro services, or not microservices, right? So we'll create some services, like 3-4 services that will take care of doing the work for us. So essentially, which means that we will break down the monolith into 3 or 4 small services, and that will intercommunicate with each other. This is still manageable, right? You can still have just 3, 4 services and manage it. But the end goal is to make sure it's all fine-grained. You actually go into the microservice architecture. So now comes the bigger part, right? So we are actually, as we break down all these services into, microservices, you're going to end up with thousands of services that is coming from the monolith application. So now, this is when we will think about managing these microservices, right? So we basically started from having a monolith, and then we put an API management in front to actually expose modern interfaces to the clients, like Google Assistant or your mobile applications or etc. And then later we thought, okay, now the best way is to actually break down this monolith into small services that give developers the best productivity. So essentially, developers can work in different teams. They can use their own languages, and they'll be their own service by itself, right? And all you need is actually to manage these services and not a single monolith application. So that's when we'll think about actually using a service mesh infrastructure. So in this case, let's say you think about using Istio, which is a service mesh. You can actually have Istio manage all these microservices for you. And you can also see a small Apigee adapter in there. So one of the points that we spoke about earlier in the starting of the session, where when you actually break down all these monolith into microservices, you're going to end up with a lot of services talking to each other. And how they talk to each other is through API. So you can see that there is also an API component, or the part of communication is through APIs, right? So between these microservices. So that's where we actually add a small adapter, which is the Apigee adapter. In this case, Apigee, which is the API management platform, has a small adapter that you can install alongside your Istio service mesh that will help you do some of these API management capabilities. Like, for example, service A to service B authentication, the keys and everything can be managed by Apigee, right? So, and also it can take some of these reports and analytics and push it back to the Apigee management console, and you can actually have a quick view of what's happening alongside your service mesh and your APIs at the same time. Okay, a quick summary of what we just discussed, right? So every company will have, every enterprise will have, their own infrastructure, layer, which can be like VMs, Kubernetes, or any other systems. And services are built on that layer, which is basically you've got your own application framework that you'll actually use to build your applications, right? And essentially, we'll end up with thousands and thousands of services which are constantly evolving, right? And we need to make sure that these services are managed, right? And some of them will be unmanaged, but our goal is to actually get all these services managed. And it's better to have a centralized infrastructure or a platform that can manage all these services for you. So that is the first part. So you basically start with your infrastructure layer, which can be Kubernetes or anything. And on top of that, you're going to have your services. Essentially, that also needs to be managed through a service mesh architecture. And also, on top of that, you might have some services might offer shared APIs. So that also needs to be managed. So essentially, at the end of the day, you want your external partners and customers to connect to your systems or your services, and that's through APIs, right? So essentially, that also needs to be managed. So if you come from a bottom-up approach, you've got infrastructure, and you've got services, and also at the end of the layer, you've got API management. So essentially, the goal is to get all the services and the APIs managed efficiently. So now let's quickly take a look at a demo where I'll walk you through how we've got like a bunch of microservices and how it can be, how you can use an API management platform to do some of these things that we just described, like, for example, authentication. Okay, so I'm opening up Cloud Shell. So what I have here is actually we saw 3 layers. Number one is Kubernetes, and on top of that you've got services, service mesh infrastructure, and on top of that we've got API management, right? So what I've done here is actually created a Kubernetes cluster, right? And I've deployed an application. I think in the previous session we spoke briefly about the hipster shop application, which is the e-commerce demo website that we created. So that's what I have here. So if I just do kubectl get svc, so it's going to list all the services that are currently deployed on this cluster. So we've got multiple services related to this e-commerce website, which is basically say ad service, cart service, checkout service, payment service, product catalog, et cetera. And if you look at what's happening here, and this is also available to access outside, if I have to see the website for this. So this is available on this IP. So if I hit that, I should see the UI, right? So this is a hipster shop that we have deployed onto the cluster, and this is a simple application, right? Simple e-commerce application. And we saw that this has got multiple services. So these are, if you look at, these are the microservices I was talking about, right? So before it might have been like one single application, like for example, e-commerce application, but now we have actually, broken it down to multiple microservices. So in this case, we have ended up with some 10 to 15 microservices that needs to be managed. So what I've also done is I've installed Istio on this to make sure these microservices are managed. So we'll see what happens when when I actually try to make a call after applying a simple policy. So I spoke about Istio. It can handle your authentication policies, right, between microservices. So in this case, right now, all the microservice calls, like calls between, like for example, product catalog might call recommendation service to get some recommendation of the products. So in this case, all of them are actually unsecure. Let's see how to secure them. Right. So here is a rule that I've applied. So I've got like a simple, API key verification system that I've put in here. So if you look at it, this is going to apply authorization policy to all the microservice calls, and we're going to manage this efficiently, right? So we'll see how we can actually create a secure call between service A to service B and how to manage them. So now, since I've enabled authorization between services, if I actually try to call the shop again, let me disable cache, and if I call the shop, if I reload the page, it is going to show 500 error, right? Because what we did was before the calls between the microservices were not secure. Now we have secured the calls. So even to show the product catalog page, we need to provide some sort of a key to access it. And this is where we'll actually use APG. So briefly, I spoke about an APG adapter that that is installed on Istio's service mesh, where APG can take care of these issuing these tokens and keys, right? And that's what I'm going to do. So I'm going to actually get a key from APG and then use it to get access to these to the services. So here in APG, I've actually configured all these services. So if you look at the services that I listed previously, all these services are configured on APG, right? And essentially what I've done is I've created an application to get a key, basically, right? So an application is where, how you would get by creating an application, you would get a key and secret on APG. And this is what I will use on the application, on the microservice service mesh to, get a get authorization working between services. So now I'm copying this key and then updating it on the UI. And then in a few minutes, the app should start working, right? So essentially, the calls between the services will start working. So what happened previously was we started with an unsecured service mesh where service-to-service calls are not secure. And then later, we applied a simple policy on the service mesh. Essentially, all the services that communicate with each other needs to have some sort of an authorization mechanism. And that is now controlled by Apigee, where the keys are issued by Apigee, and we need to update the key onto the services to make sure they can call each other. And that's what we are seeing now, right? So we'll also see how this happened. If you look at the trace, so other aspect I spoke about service mesh was the monitoring and tracing. So since we end up with all these different services, we need to make sure we are able to monitor these microservices. So let me actually start a trace session for you guys. So this opens up the default trace tool that comes with Istio, which is Aegir. So in this case, it gives you the services, the same services that we saw earlier, and you can choose to trace whichever service you want. So we'll trace the product catalog service. So I'll get some traces, and we should be able to see the traces that happened in the past few minutes, right? So I also make a simple call here so that I can show you the end-to-end working of how the call comes to the service mesh, goes to Apigee, gets the key, verifies, and then comes back. So I'm making a couple of calls here. And then I'll go and find traces that should show up. So this is the recent call that we made. So what happens here is I made a call to product catalog service here, which was this. I made a call to product catalog service, which gives just a simple response of product catalog. And here, in the trace screen that I've actually got, I can see the whole trace of what happened in the previous call, right? So we made a call to the product catalog service, and then it actually went to the Istio policy check, and then it went to Apigee to check for the API key, and then it came back and gave us a result. So this is what happened with Apigee. So now what I'll do is I'll disable Apigee, right? So I'm going to disable Apigee's API verification. kubectl delete. Oops. So what this will do is actually it is going to go back and delete the rules that we have created. In this case, now the service mesh is back to being unsecured. The service-to-service calls are not being secured by Apigee. So now if I just do a call to the products, I should get, without the API key, I should get a response back. Now, I didn't even use an API key, and I got a response back, right? So if I also go to the UI and update the API key to some random value, save it, and call the service back again, so essentially we have disabled the Apigee API key verification now. So that's the end-to-end story on how the service mesh infrastructure and API management interplay together. And so what we looked at was how actually we broke a monolith into different microservices. And since we have these thousands of microservices, they need to be managed efficiently. And that's where your service mesh comes into the picture. That is going to give you the ability to connect, secure, monitor your microservices. And on top of that, we also saw how an API management could come into the picture, and then we'll help you with centralized management of your service mesh APIs and also your external APIs, right? So that's what we saw in this demo, and yeah, that's all I had for this session. So if you have any questions, I'll be outside, and thank you.